If this is the first time you've thought about inverse trigonometry, this problem is going to look a little weird. What inverse trigonometry is just doing what you're used to backwards. So normally I would say something like, dear student, what is the sine of pi over 2? And you would say, oh, that's just 1. You're used to going forward. You're used to me giving you an angle, and we put that angle into a sine function, and you find the value. Now we're going backwards, meaning I tell you something a little bit differently phrased. I say, the sine of some angle is -1. What was that angle? Now, the way I do this problem, if it's sines and cosines, those are pretty straightforward, especially if you've memorized your unit circle, which you should. I think, okay, sine is the y-coordinate. Where is the y-coordinate -1 on the unit circle? Oh, right there. There's only one spot. What angle is that? Well, that's 3 pi over 2. That's it. So let's try another one. Let's think about the cosine of some angle, which gives me 1. So where is the cosine equal to 1? Well, cosine is the x-coordinate. Okay, so the x-coordinate is 1 right there. And that is the angle 0. Cool. Let's try something a little different. Let's do something where you have a value like this. The cosine of some angle equals negative radical 3 over 2. Now, this is going to get a little more interesting. Negative radical 3 over 2. First of all, it's negative. That means the x-coordinate is on the left side. So we're somewhere over here, right? Well, negative radical 3 over 2, that's a pretty big value. It's not as big as 1, but it's pretty big. And that's going to be the one that's located like right here. But there's actually 2 places. The cosine of each of these green dots, each of these green angles that I just drew right there. The cosine of, what is this? 5 pi over 6? Cosine of 5 pi over 6 is negative root 3 over 2. And the cosine of 7 pi over 6 is also negative root 3 over 2. So in this case, when there's more than one angle possible, I want you to just pick one of them. This is not the way it's normally going to be when we do inverse trig. Normally, we restrict the domain. And there will be a right answer and a wrong answer. And there's a way that we typically decide which one of these 2 green dots we're going to choose. But in this case, we're just getting our feet wet with the idea. Just pick whichever one you like. So, we could pick 5 pi over 6. And that would be right. And 7 pi over 6, that would also be right. Because they would both satisfy the equation. All right, now some of these things are going to look a little weird. Like, here, how about this guy over here? Let's talk about secant. And where is that a DNE? Well, if you remember, secant of theta equals 1 over cosine of theta. Now, how do you actually get a DNE? Do you guys remember how to get a DNE in math? You have to divide something by 0. So in other words, something like that. 1 divided by 0 does not exist. It's infinity, or whatever you want to call it. So where's the cosine of 0? That's what this is asking. Secant equal to DNE? That's like saying, where is cosine equal to 0? Well, cosine's equal to 0 here. Cosine's also equal to 0 here. So you can pick whichever one you like. If you said pi over 2, that's correct. Secant of pi over 2 is DNE. Okay, and you go through this process for all of these things. The tangents, the cotangents, it's the same idea.